Your Ford EcoBoost has a turbocharger that is working harder than you think, and 7 everyday driving habits are slowly destroying its wastegate without you realizing it. The wastegate is a small but critical valve that controls how much exhaust gas reaches your turbo's turbine wheel. When it works properly, it regulates boost pressure and keeps everything within safe limits. When it fails, you are looking at lost power, check engine lights, and a repair bill that can hit $2,500 or more, because Ford integrates the wastegate directly into the turbocharger housing, and you often cannot replace just the wastegate alone. You end up buying a whole new turbo assembly for a component that costs about $35 on its own. I have been working on Ford trucks and SUVs for over 15 years, and I have watched wastegate failures skyrocket as more EcoBoost engines hit the road. The 2.7 liter, the 3.5 liter, the 2.3 liter, and the 1 liter engines all use internal wastegates, and they all suffer from the same owner-caused damage patterns. The frustrating part is that most of this damage is completely preventable. Owners just do not know what they are doing wrong. Today, I am walking you through 7 habits that are melting, sticking, and destroying your wastegate. Habit number 5 has caused more wastegate seizures than anything else I see in the shop. And habit number 1 is so common that I estimate 9 out of 10 EcoBoost owners are doing it right now without realizing the damage they are causing. Let us get into it. Habit number 7, ignoring your oil change intervals. This might sound basic, but it is the foundation of every turbo failure I have seen, and the wastegate is no exception. Your EcoBoost turbo spins at speeds exceeding 150,000 revolutions per minute in the larger engines, and over 200,000 revolutions per minute in the smaller displacement motors. At those speeds, the bearings inside the turbo's center housing depend entirely on clean, properly viscous oil to survive. When oil breaks down from extended use, it loses its ability to resist extreme heat. That degraded oil does not just hurt the bearings, it bakes onto internal turbo surfaces, including the wastegate actuator linkage and the valve seat where the wastegate flap meets the housing. Here's what happens mechanically. As old contaminated oil circulates through the turbo, it leaves behind varnish and carbon deposits everywhere it touches. These deposits gradually build up on the wastegate pivot points and the actuator rod connection. Over time, the hole where the actuator arm connects to the wastegate flap becomes oval-shaped from wear, accelerated by abrasive contaminants and dirty oil. Once that connection develops excessive play, the wastegate cannot close fully. Boost pressure escapes through the gap, the engine will throw a P0299 underboost code, and you will lose noticeable power. Ford's recommended oil change intervals for EcoBoost engines often stretch to 10,000 miles under their normal driving schedule. That number is too long for a turbocharged engine that sees real-world use. Under severe duty conditions, which include towing, frequent short trips, extreme temperatures, and stop-and-go traffic, that interval should be cut in half. Change your oil every 5,000 miles using full synthetic oil that meets Ford's specific specification. For most current EcoBoost engines, that means oil meeting the WSSM 2C960A1 standard. Do not guess on this. The wrong oil specification accelerates thermal breakdown and increases the coking risk inside the turbo housing. If you have been stretching your oil changes and notice a metallic rattling sound on cold starts that disappears once the engine warms up, that is likely wastegate rattle caused by worn linkage. At that point, the damage is already done, and the only permanent fix is replacing the turbocharger. Habit number 6, flooring it on a cold engine. This habit destroys turbo components faster than almost anything else, and it is especially destructive to the wastegate. If you start your EcoBoost on a cold morning and immediately hammer the throttle, you are asking the turbo to produce maximum boost before the oil has reached proper operating temperature. Cold oil is thick and sluggish. It does not flow through the small oil passages in the turbo center housing efficiently. That means the bearings and internal components run with marginal lubrication during those first critical minutes. The wastegate damage goes deeper than lubrication alone. When you request full boost on a cold engine, the wastegate actuator must respond aggressively to control boost pressure. The actuator linkage is metal that contracts in cold temperatures, and it is being forced through its full range of motion before it has had time to thermally expand to its normal operating dimensions. That creates excessive stress on the pivot points and on the actuator rod. On the 2.3-liter EcoBoost used in the Mustang and Explorer, Ford actually issued technical service bulletins 160121 and 160122 addressing wastegate actuator rods that were popping free from the lever arm. A loose clip would back off, the wastegate would hang open, boost would die, power would flatline, and the engine would throw a P0299 code. Cold, aggressive driving accelerates exactly this type of mechanical failure. The solution requires patience. After starting your EcoBoost, drive gently for the first 3 to 5 minutes. Keep the RPMs below 2,500 and avoid heavy throttle inputs until the engine temperature gauge begins moving toward the normal operating range. You do not need to sit and idle for 10 minutes like the old carbureted days. Modern fuel injection does not require that. But you do need to give the oil time to circulate, warm up, and properly lubricate every turbocharger component before asking it to produce serious boost. This one simple habit change can add years of life to your wastegate and turbocharger. Habit number 5. Extended idling without driving. This is the wastegate killer that nobody talks about. Many Ford EcoBoost owners start their trucks and let them idle for extended periods to warm up in winter or to cool down the cab in summer. Some people sit in parking lots with the engine running for 20 or 30 minutes at a time. This seems harmless, but it creates conditions that directly attack your wastegate's ability to function. When an engine idles, it operates at low temperature and minimal load. The combustion process is inefficient because the cylinders never reach optimal operating temperature. On a direct injection EcoBoost engine, this is particularly damaging because incomplete combustion creates oil vapor and fuel residue that the positive crankcase ventilation system routes back into the intake. Without the cleaning effect of high-temperature operation, this contamination accelerates carbon buildup throughout the engine, including on the turbo's exhaust side where the wastegate lives. But there is a more direct problem happening at the wastegate itself. During extended idling, the turbo does not spool. The wastegate sits closed in a bath of relatively cool exhaust gases that carry moisture and combustion byproducts. These byproducts condense on the wastegate flap and its seat, creating a corrosive environment that promotes rust and carbon adhesion. Over time, these deposits cause the wastegate to stick in the closed position. A stuck closed wastegate means the turbo has no pressure relief mechanism. Boost pressure climbs past safe limits, creating an overboost condition that can damage the engine, the intercooler piping, and the turbo itself. I have inspected wastegates on trucks that idled extensively for work purposes, contractor trucks left running at job sites, police vehicles, delivery trucks, and the carbon buildup on the wastegate valve and seat was so severe that the flap could not move freely. The solution is straightforward. Do not idle your Ford EcoBoost for more than 2 to 3 minutes. If you need to wait in your vehicle for extended periods, shut the engine off. In winter, limit warm-up time to 2 minutes maximum and then start driving gently. The engine reaches operating temperature much faster under light load than it does sitting still. This single habit change protects your wastegate from the carbon accumulation and corrosion that cause the most common and expensive failures. If you are enjoying this information, go ahead and smash that like button and make sure you are subscribed because we are about to get into the habits that cause the most expensive wastegate damage I see in the shop. Habit number 4. Shutting off immediately after hard driving. Here's a scenario I see constantly. An owner tows a trailer across the state, pulls into a rest stop, shuts off the engine, and walks away. Or someone exits the highway after driving at high speed for an hour and parks in a driveway, turning off the ignition immediately. This instant shutdown after sustained high boost operation is devastating to turbo components, including the wastegate. During hard driving, your turbocharger is processing extremely hot exhaust gases. The exhaust side of the turbo, where the wastegate is located, reaches temperatures that would make you uncomfortable if you knew the actual numbers. When you shut off the engine immediately after this kind of operation, several bad things happen simultaneously. The oil pump stops because it is driven by the crankshaft. Oil flow to the turbo center housing ceases instantly. Whatever oil remains in the turbo bearings and surrounding passages begins to bake from the residual heat soaking through the housing. This is called coking. The oil literally turns into hard carbon deposits that chew at shaft seals and bearings. Now, Ford engineered the EcoBoost turbos with water cooling and a passive thermal siphoning system that continues to circulate coolant through the turbo after shutdown using convection. This system works well for normal driving conditions. But after sustained high-load operation, towing heavy on the highway, running hard through mountains, or extended high-speed driving, the thermal load can exceed what the passive cooling system handles effectively. The wastegate actuator, which sits on the exhaust side of the turbo, absorbs tremendous heat during these conditions. Immediate shutdown traps that heat in the actuator mechanism, accelerating wear on the diaphragm, spring, and linkage components. The fix is simple and costs you nothing but 60 to 90 seconds of patience. After any sustained high-boost driving, let the engine idle for about 1 minute before shutting it off. This keeps the oil pump running, continues active coolant circulation, and allows the turbo housing temperature to stabilize. If you are coming off a long highway drive, the last few miles through surface streets at low speed serve the same purpose. You are naturally reducing the thermal load before parking. It is the drivers who pull directly off a highway into a gas station and immediately kill the engine who see the worst wastegate actuator failures. Habit number 3, running boost leaks without fixing them. A boost leak anywhere in your EcoBoost's charge air system forces the wastegate to work overtime, and most owners do not even know they have one. Boost leaks occur when pressurized air escapes through cracked intercooler hoses, loose clamp connections, a damaged charge air cooler, or deteriorated couplings anywhere between the turbo's compressor outlet and the intake manifold. Here is why this destroys your wastegate. When pressurized air leaks out of the system, the engine computer detects that target boost pressure is not being reached. It responds by commanding the wastegate to stay closed longer, forcing the turbo to spin harder and produce more boost to compensate for the lost pressure. The turbo is essentially chasing a target it can never reach because air keeps escaping. This puts the wastegate in a constant cycle of aggressive operation, opening and closing more frequently and more forcefully than it was designed to handle. The actuator motor or diaphragm wears out prematurely. The wastegate flap and seat see increased thermal stress because the turbo is running hotter than intended. Exhaust gas temperatures climb because the engine is working harder under the boost deficit. Common signs of a boost leak include a noticeable hissing or whooshing sound under the hood during acceleration, reduced power that comes and goes, and inconsistent boost readings if you have a gauge. Many owners dismiss these symptoms as normal turbo noise or blame other components without checking the charge air system. A smoke test is the most reliable way to find boost leaks. A technician introduces smoke into the pressurized side of the intake system and watches for visible leaks. This test typically costs $100 to $200 at a shop and can save you thousands by identifying a $30 hose clamp problem before it destroys a $2,000 turbocharger. If you notice a loss of power, especially intermittent power loss during acceleration, have the boost system pressure tested before assuming the turbo or wastegate is the problem. Many wastegate replacements I have seen were completely unnecessary because the actual failure was a cracked charge pipe or a loose intercooler connection. Habit number 2, using cheap oil or the wrong viscosity. This is closely related to habit number 7, but it deserves its own spotlight because of how Directly, it affects wastegate longevity. The oil flowing through your turbocharger is not just lubricating the bearings, it is also cooling them and carrying heat away from internal surfaces. When that oil is the wrong viscosity or lacks the proper additive package, it breaks down faster under the extreme thermal stress inside the turbo housing. Ford specifies particular oil standards for EcoBoost engines for a reason. These specifications ensure the oil contains advanced additives that resist thermal breakdown and prevent the coking that commonly affects turbocharged engines. Conventional oil or bargain brand synthetic that does not meet Ford specification simply cannot handle the heat generated by a turbo spinning at over 100,000 revolutions per minute. The oil bakes onto hot surfaces faster, and those baked-on deposits accumulate on every component the oil touches, including the wastegate actuator, the wastegate valve stem, and the exhaust housing around the wastegate seat. I have pulled turbos off EcoBoost engines where the owner used conventional oil or the wrong viscosity grade for years. The wastegate actuator was completely seized with carbonized oil deposits. The repair required a full turbocharger replacement because the wastegate is integrated into the housing and cannot be serviced separately on most EcoBoost applications. That repair can cost $1,500 to $2,500 in parts and labor, depending on the engine variant. The 3.5-liter twin-turbo is the most expensive because you are often replacing two turbo assemblies. Using the correct oil also means paying close attention to the viscosity grade. Ford does not recommend a specific weight just for fun. The viscosity rating ensures proper oil flow through the tiny passages in the turbo center housing at all operating temperatures. If the oil is too thick, it will not reach critical surfaces fast enough during cold starts. If the oil is too thin, it will not maintain adequate film strength at peak operating temperatures. Either extreme accelerates wastegate wear. Check your owner's manual for the exact oil specification. Use full synthetic oil from a reputable brand that explicitly states it meets that specification on the bottle. This is not the place to save $5 on an oil change. Habit number 1, towing heavy in the wrong drive mode. This is the most damaging wastegate habit I see, and it is so widespread that I would estimate the vast majority of EcoBoost owners who tow are making this mistake right now. When you tow a heavy trailer in normal mode, or worse in eco mode, you are slowly destroying your wastegate and the turbocharger around it. Here is the mechanical reality. In normal mode, the transmission shifts to higher gears earlier and stays there longer to maintain low revolutions per minute and maximize fuel economy. When you are pulling a 7,000-pound trailer, this forces the engine to lug under heavy load. The turbo has to produce maximum boost at low revolutions per minute to compensate for the lack of mechanical advantage from higher gearing. The wastegate is constantly modulating under extreme thermal load because exhaust gas temperatures are elevated from the engine straining against the load. This sustained high-temperature operation accelerates every form of wastegate wear. The actuator diaphragm degrades. The linkage develops play. The wastegate valve and seat warp from repeated thermal cycling under stress. Eco mode makes everything worse. It reprograms the throttle to deliver less power, the transmission upshifts even earlier, and on turbocharged engines, the wastegate opens more frequently to limit boost pressure. That might sound like it would reduce wastegate stress, but the opposite is true. By limiting boost and power output, eco mode forces the engine to work harder for longer periods to maintain speed while towing. Exhaust temperatures climb because combustion is less efficient under these lugging conditions. The wastegate cycles more frequently between open and closed positions as the engine management system fights between the eco mode efficiency programming and the actual power demands of hauling a heavy load. Ford specifically recommends tow haul mode when pulling heavy trailers, but they do not make this obvious enough. Tow haul mode provides aggressive downshifting, keeps the engine in the revolutions per minute range where it produces power most efficiently, and manages exhaust gas temperatures far better than normal or eco mode. The wastegate operates in a more controlled, steady state rather than constantly cycling under extreme thermal stress. The solution is clear. Anytime you are towing more than 3,000 pounds, engage tow haul mode. This is not optional for wastegate longevity, it is mandatory. The transmission shift programming in tow haul mode protects the entire turbo system by keeping the engine operating where it is most efficient and least thermally stressed. I have seen wastegates fail at 60,000 to 80,000 miles on trucks that towed regularly in normal mode. I have seen identical trucks that use tow haul mode consistently run past 150,000 miles on original turbos with no wastegate issues whatsoever. The drive mode you select directly determines how long your wastegate survives. If you have been towing in normal or eco mode and you are experiencing wastegate rattle on cold starts, a metallic rattling sound that disappears as the engine warms up, or if you have noticed reduced power under load, have your turbo system inspected immediately. Early wastegate problems can sometimes be addressed by replacing just the actuator on certain engine variants, which is far cheaper than a full turbo replacement. But once the wastegate valve and seat are damaged from prolonged thermal abuse, the entire turbocharger assembly has to come out. Here's the bottom line. Your Ford EcoBoost is an impressive piece of engineering that delivers serious power from a relatively small package. But that power comes with responsibilities the dealership never explained to you. The wastegate is the turbo's pressure relief valve, and every habit I covered today puts unnecessary stress on it. Change your oil on time using the correct specification. Do not beat on a cold engine. Stop idling for extended periods. Give the turbo a minute to cool after hard driving. Fix boost leaks before they cascade into turbo damage. Use the right oil viscosity, and for the love of your engine, use tow haul mode when you are pulling weight. These 7 habit changes cost you nothing but awareness, and they can save you thousands in turbocharger replacements that Ford will happily sell you at full dealer markup. Take action on these today. If you found this valuable, make sure you subscribe, hit the notification bell, and drop a comment telling me which of these habits you have been guilty of. Share this video with every EcoBoost owner you know, because most of them are making at least 2 or 3 of these mistakes right now without knowing it. And if you want to learn about the hidden settings that are also quietly damaging your Ford, check out this video right here. I will see you in the next one.